Hello everyone. So today we're going to solve another dynamic programming question called word break. And as the question suggests, given a string S and a dictionary of strings word dict, return true if the S can be segmented into space separated sequence of one or one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in a segmentation in the segmentation. So basically we'll give a array of words that we're going to consider that a dictionary of words. Then we'll be given a string and you have to find out that that particular string can be constructed using those words of that word list or dictionary. And it says that we can pick a word multiple times. For example, when it's a lit code, in example 1 the string is lit code and the word dictionary is lit code and so on, lit and code. So it says that we can consider lit multiple time and code multiple time to see if the particular words can be a particular given string can be constructed using the words from the list. So we have like 3 examples here and I have written test cases. So now see how we're going to create the decision tree, because this problem can be solved using recursion as well as then we're going to try to write it using efficiently using dynamic programming. So let's see how we're going to convert it into a recursion problem. So let's consider that we have a word called maybe lit code. Let's take the same example because this is one of the famous lit code problem anyway. So let's string equals to lit code and word equals to so let the string equals to lit code and the words equals to lit and code. Okay. So now then, if you see here, let's do it like this. It goes like this. Words equal to lit and code. Okay. So if you see that in lit code, we can pick L, okay, first letter for the string, right? And you're going to compare that if the L is present in this particular string, right? And also when you pick L, the rest of the word become from E to code, right? We choose L to compare in the dictionary. The rest of word is like now it code. So we're going to compare, is it present in the list? Present in the list? No. Then we're going to increase the pointer here. Now the word becomes LE. Is LE present or not present? If LE presents, again the rest of the words become like ET code, right? LE present? No. LE present? No. Present? No. Other words, is it code present? No. Again, same way, you're going to increase the pointer. So when the pointer will come to the 0 1 2 0 1 2 3 third position, right, we are going to see the left will become the left when the pointer become like 3, our, because the pointer become 3, our word will become lit, and the rest of word will become now code. So we are going to see, is lit present in here? So yes. If yes, now we are going to also check, always check for the other words. For example, when you are going to put lit, then you are going to compare that from the it code. Then when you are going to compare to it, again pointer to 1, then our left side will become LEE. So we are going to pass, we are going to see if this is present, and we are going to also pass the rest of the word like code to the string, to the same function to check if it's present or not, right. So we just breaking the same thing. You got, hope you got the idea, because we are checking the L, for example, we are taking a word and checking it present in the word. Same time, when we increase the pointer, we are getting new words and keep checking the same word if it's present or not on the same logic. So when it becomes 3, we're going to put it yes, then again it's going to send code to the function and check its code present. So now you're going to find yes. If the all of the function returns yes, means true, then we have the word. But if you don't have the word, for example, there is another word called x here. So what happened? It's going to code x, and by the time it reach the end of the string, right, by the time the pointer reach end, till we don't have any word match, at that time we are not going to find any match when it reaches the end, if there is no match, and at that time by default you are going to return false, and it should work. So the concept is like we are breaking the, we are taking every letter from the string, the given string, and we running the function to check if that present in our dictionary. In the same time, if we at the same time we are creating the rest of the word, or suffix, and also checking the suffix is present or not, and keep doing same by incrementing our pointer, so that we get got it checked for every combination of the substring of that particular word. So that is how the concept works. So now let's see and try to put it in code. So how it's going to work is like if, so at the end of the if our word present, right, at the end our s will become null, or because the word will word will be found in the dictionary, and our next s will become, when the pointer moves, the next s becomes null. So at that time we're going to just check, if not s, we just have to return true. That's it. It's simple as that. Else we have to iterate. Oh, come on. We have to iterate through the string, right, and then let it call it char character, and come on, character, and then what are you going to do? First you're going to create let suffix. We don't have to find character here, because we have to find the suffix. Now the suffix will be like string dot substring 0 to that particular I. So it will give us from 0 to every word, right? So when it's 0, it becomes 0 0, so it may not return anything, so it always will be +1, right? Should be the index +1, so we can write +1 here easily, or we can start it from 1. This will be like less than or equals to 1, so that we include we can run the loops for last character as well. Now then, we got the suffix. Now if you get the suffix, we have to find let is present. Let is present. So we're checking that if substring is, for example, as we discussed in the whiteboard, for every letter we will be checking if it's present in our dictionary, right? So dict includes suffix. It will give us true or false. And if it present, so if is present, right, then we have called the recursion. I'm just breaking it, the code. This can be written in a compact way, right, in one liner or something, but I'm just breaking it so that we can decipher or make sense of the logic. So now if the suffix is present, then we have to find the rest of the word, right? Rest of the word, or we can call sorry, this is a prefix. I'm sorry, prefix. So we can call now this kind of suffix, or the rest of the word, because if your prefix is missed, then we have to find the rest of the word. So the rest of the word will be like s dot substring I, and we will be running. So now we're going to find is, let is rest is suffix is suffix present, right? So we're gonna create word break recursion, then we're gonna say s equal to suffix and dict. Got the point? So if we find the suffix, right, and suffix is present, then we if prefix is present, then you find the suffix, or suffix is present, suffix of the string, then we run the same loop to check if suffix is present or not. So what happened? This is going to take the rest of the word and put the same logic, and if at the end, if x becomes null, it's going to return true. If this becomes true, this each suffix present must be true. So if each suffix present, right, return true. If each suffix not present at the end, right, if coming out of for loop, we just have to return false. So this should solve our problem, and let's see and run our test cases. So all of our test cases has passed, and this is how it is. But let me show you how to write it in very less code. So what are you going to do? We can just let's comment it out, and we can write it like for in few code, like for, let me for I as right I plus plus, then we're gonna write for like if dict dot includes your s dot substring and a 0 to I, and word rec dot, you're gonna find s dot substring I and dict return true. Yeah, this is a single line, can solve it. Let's try again. What have I done? What happened? Where I messed it up? Oh, sorry. Here you have to check for the last character as well, and you have to start from 1, because otherwise the first character will become space. So good. So that's how I write it, but it's better to like write in a way, in a readable way, rather than writing it in a single line, because it's better for you to understand. It's better for someone who is reading your code as well, understand the code. For easy for that person to even understand your code. So I would go with this one rather than this single lines. Anyway, so now the same thing can be written in using dynamic programming. So let's try and see how we can write the same thing using dynamic programming. So now then, we have the same example, that we have the word that is lit code, and our dictionary dix is lit and code. So now let's create a DP, or keep track of the words from left to right. So we're going to take a single character for the at the end. It's always will be true. Let's start at true with our length plus 1th position. And now what's going to happen, if we at E, we're going to see, is the E present in dict? Is present in dict? Yes and no, right? If no, that will become false. Then again we're going to keep building this string. Now we're going to take D. Is DE present? No. Put it so false. Now you're going to take O. Is ODE present? No. False. Now when you go to code, code is present. Code is present, and we have to check. So when code is ended, some new word might have started here. That must also have inside our DP, right? Then only you're going to do, not a single code, single word code. We cannot consider only one position. We also have to see when code ends, the other word that starts after code in our string should present. So that will be indicated by the, when we put this current position, is code present? Yes. So what are you going to do? Code the length equals to 4. So from the current position, that is 0, 0, 1, 2, 3 and 4. 4 plus 4, that is 8, 4, 5, 6, 7, 8. So the when code ends, the new or the another word after code already we calculated also present. So so we have to do like this, whatever true between this, right? So we have to copy that true to here. So it is present there. So this also present. And we have to reset this word. It's already present. So now again we're going to start from T. T present? No. ET present? No. EET present? No. Now we're going to get lit. Hey, lit is present. So when lit presents, whatever the rest of the word code, is it already present? We're going to find this from here. So 0 plus length of lit, that is 4, that is position 5. Position 5, position 4, that is 0, 1, 2, 3, 4. 4 is equal to true. So whole word is present, and we have to return that true. That's how the DP works, right? We're going to keep maintaining the searched words if it's present or not, and the previously searched word after this word that we are searching for is already present or not, and we're going to return at the end the last calculated value, that DP of 0, that will contain our answer. So now let's try to put that in our code. So first we're going to create like let DP equals to array, then s dot length plus 1, and you're gonna fill it with true. We're gonna fill it with true, or we're just gonna fill it with 1, because in JavaScript will give the same result for either 1 or 2, right? Let's fill it with 1. Now we have to write a for loop. Let I equals to, now I gonna start from length minus 1 dot length minus 1, and we're gonna do it until I is greater than or equals to 0. Then we're gonna do I minus minus, right? Now we're gonna construct the word, and that's why let's create a temp word here. Let temp equals to space, right? And then when you go from right to left, we're going to construct the word is like temp equals to that word, because we are going from right to left. We have to add the character first, or at I plus temp. So this will give us the word, and we have to check if temp, so if dict includes, either we're going to check every word with every word in the array by iterating if the word is present, or we're just going to use the includes function, default in array JavaScript function, to check if it's present in the array, or we can just iterate to the dict array and check if anything is matching or something present. So we're going to use the includes method, inbuilt method, and we're going to check is temp. Right. If temp present, then what are you going to do? Our DP of I equals to DP of I plus temp dot length, right? We have to copy the previously calculated word. If it's already present, the next word is already present or not, so that we have to mark it true, that okay, the both words are present now. And we have to reset the temp, right, so that we can construct again a new word to check. From where this came now. Yeah, okay. Else our temp, DP of I equals to false, that is we can make it with 0. Let's do one thing. Let's populate it so that at the end, when we will be returning our result, we don't have to again convert it. But anyway, I think one will consider a truthy anyway. Let's see. At the end, we have to just return dp of 0. I think this should do our trick, and let's try to run our code. This is the dp1. There we go. All the test cases have passed, and that's how we do our DP programming for WordBreak. Thank you.